Dear students, today we are studying about the 16th lesson, understanding shapes. And this is a plane. This is a plane surface, and we can draw some shapes here. That is, these are all shapes. These are all shapes. But this in mathematics, these shapes are called curves. These shapes are called, all these shapes are called curves. But that's, you have a doubt about that. What is it? This is a straight line picture. That is, this is a straight line picture. This is a straight line, and this is a straight line. Here it is a straight line. Then how it is called a curve? But that is, the word curve means not straight lines. That we know that the word curve means C-U-R-V, curve means not straight line. But in mathematics, a straight line is also called a curve. In mathematics, the straight line is also called a curve. So that we can say that these pictures are curves. All these pictures are curves. Okay, there are different types of curves. There are three types of curves. That is, first one is open curve. Open curve. What is an open curve? A curve does not cut itself. A curve, that is, this is a curve, but it does not cut itself anywhere. That is, and again this is a curve, and here also this curve join here, and then here, and that it does not cut itself here, and here is also this curve is not cutting itself. These curves are a curve does not cut itself is called an open curve. This is an open curve, this is an open curve, and this is an open. This is not closed. This is not closed. That is an open curve. And here the second one is a closed curve. This is not open. It cuts the curve which cuts itself. The curve which cuts itself. That is, here it is joining here, and here also. Here it is this curve joined and cut itself in various parts. That these curves are called closed curve. A curve which cuts itself are called a closed curve. The third one is a simple closed curve. A simple closed. That means when a curve is said to be a simple closed curve, it does not pass through any point of it more than once. That means it does not pass through. This is a curve and this is a curve, and here it is joining here, and then it does not pass through any other points. That is, again in any other point. So that this is called a simple closed curve. This is also a simple closed curve. This is a closed curve also, and also a simple closed curve. And this is also a simple closed curve. Simple closed curve means it does not pass through any point of it more than once. That is, it doesn't pass through any other points. That is, here it is only joining one point, and not more than any other points. That is called a simple closed curve. Okay, a closed curve, if it is a closed curve, this is a closed curve, and this closed curve divided into three parts. That is if it is this is M1, M2, M3, and then A1, A2, A3, A4. Okay, and here this closed curve divided into three parts. That is, first one is this interior part. The interior part of this closed curve is equal to the interior part. Interior part is equal to, what are the interior points inside this? That is equal to P1, P2, P3, P4. This is the interior part of this closed curve. And then this, and the boundary. Second one is the boundary. This is the boundary. The boundary of this closed curve. And what the points in the boundary is equal to BOUNDARY. Boundary is equal to M1, M2, and M3. And next part is the exterior of this closed curve, exterior of this closed curve, that is equal to this A1. This is the exterior portion of this closed curve, and this is equal to A1, A2, A3 and A4. What is this? This is the interior of this closed curve. This is the interior portion, and here this is the interior portion, and then this is the boundary of this closed curve, and then this is the exterior part of the closed curve. And the interior of the closed curve, and the boundary, together with the boundary, the interior portion and together with the boundary is called the region of this closed curve. Is called the region, REGION, region of the closed curve. The interior portion and the boundary together with the boundary is called the region of this closed curve. Next is a polygon. What is a polygon? Polygon, that is a royal picture here. That is here. This is a polygon. That you know that this is a closed figure. That is, what is a polygon? A polygon means it is a closed plane figure bounded by straight line segments. That is, it is a closed plane figure. This is a closed figure. And that is bounded by a, this is the boundary of this closed figure. And this is connected by bounded by a straight line segment. Bounded by straight. This is straight line. And it is a straight line, and here it is bounded by. Here this polygon is bounded by 4 line segments. That is called a polygon. And then here there is a statement about polygon. The line segment forming a polygon intersect only at endpoints. Forming a line segment intersect only at endpoints, and each endpoint shared by 2 line segments. That is, this is a line segment, and here is also a line segment, and here is a point that is intersect at this point, and here it is a line segment, and here it is a line segment, and here also this is a point, that is end point. This is an end point, and here there are 2 line segments. Here is also an end point, and here this is a line segment, and here there is a line segment. That is, this is about the polygon, and there are some points about polygon, and we'll discuss about that. Okay, here there are some figures, and we can check whether this is a polygon. These figures are polygons or not. Here this is the first figure. That is A, B, C, D, E, F, G. And here these are the endpoints. This A is an endpoint. B, C, D, E, F, G are endpoints. And here we know that for each endpoint, A, for this endpoint A, there are 2 lines joining with 2 line segments. B joining with the 2 line segments. C joining with 2 line segments. And D, E also have 2 line segments joining, and this is also a closed figure. That's, we can say that this is a polygon. Satisfies the conditions of polygons. And then here second one, A, B, C, D, E. This is a figure. Is this figure a polygon? That we know that E is not an endpoint. That E is not an endpoint. That here it is, this point there are 4 line segments joining, so that this is not a polygon. Here there is E is not an endpoint, so that we can say that this is not a polygon. And then third one, here this is a point A and this is a point B, and here look at here, there are 3 line segments. This is one, and this is second one, and third one. Each endpoint has 3 line segments. That A has 3 line segments and B has 3 line segments. As per the conditions of polygons should have only an endpoint with 2 line segments. Here there are 3 line segments, so that this is not a polygon. And the fourth one, first of all, this is not a closed figure. A polygon is a closed figure, but here this figure is not closed, so that this is not a polygon. And here A and E, as no, this is not an endpoint because here only one line segment. No two line segment for here, so that this is not a polygon. Polygons are named according to the number of sides they contain. Okay, polygons are named, the name of the polygons based on the sides they contain. Here there are three sides. These are sides. These are called sides, and we know that that is the line segments joining the point. This point is called the vertex of that polygon. And here there are three vertices for a polygon, and this is called the line segment and side. Here there are three sides. That is one, two, three sides, and with these three sides we can see that the name of this polygon is triangle. The name of this polygon is triangle. Here for this polygon there are four sides. One, two, three, four. Four sides, and a four-sided polygon is called a quadrilateral. We know that there are many types of quadrilaterals are there. That is squares, that is rhombus, rectangles, etc. And every four-sided polygon, that is a quadrilateral. Here there is four sides, and this is called a quadrilateral. And then next is a polygon with five sides. That is 1, 2, 3, 4, 5-sided polygon. And this polygon, five-sided polygon, is called a pentagon. And here we know that that is penta. Penta means 5. That is, here it is 5 side. A 5-sided polygon is called a pentagon. And here there are 6 sides. 1, 2, 3, 4, 5, 6. 6 sides. And 6-sided polygon is called a hexagon. And then here it is 8-sided. That is 1, 2, 3, 4, 5, 6, 7, 8. 8-sided polygon. 8-sided polygon is called octagon. And then here it is a 10-sided polygon. That is, it looks like a car. Is it? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this 10-sided polygon is called a decagon. A 10-sided polygon is called a decagon. That means the polygons are named according to their number of sides. And this side, this is the sides. For this here, this is the side, and this is the vertex. And the plural form of vertex is vertices. Here there are 4 vertices, and here there are 3 vertices, and 1, 2, 3. These are the vertices that you already studied in the previous classes about vertices. Here 1, 2, 3, 4, 5, 6. 6 vertices. And these are the names of this polygons. These names of this polygons. Okay, next is types of polygons. There are 2 types of polygon. That is, one is a convex polygon and the second one is a concave polygon. What is a convex polygon? If each angle of a polygon is less than 180 degree. If each angle of a polygon is less than 180 degree, that here this is a convex polygon. That is, every angle is less than 180 degree. That is less than 180 degree. That is called a convex polygon. That is, every angle. That is, here the angles are, we know that the angles are, here we draw a diagonal. That is, we know that here we get three triangles. Here we get 3 triangles, and we know that the sum of the 3 angles of a triangle, 3 angles of a triangle is 180 degree. Here this is less than 180, and here it's also less than 180 degree. And these angles are called convex polygon. And here, if I draw a picture, and this is a polygon. Okay, this is a polygon, and here it is, this angle is greater than 180 degree. This angle is greater than 180 degree, and at least one angle. If at least one angle of a convex concave polygon is 180 degree, that is called a concave polygon. If at least one angle of a polygon is more than 180 degree, this is less than 180 degree, and this is more than 180 degree, this is called a concave polygon, and this is called a convex polygon. And unless if the name of a polygon is not stated, if it is a concave or a convex polygon is not stated, that it is a convex polygon. That is, it is a convex polygon. Unless the name of the polygon is not stated, a polygon means it is a convex polygon. That is, next, okay, we calculate the sum of the angles of a polygon. If the sum of the angles of a polygon, and here are some polygons here, and Draw a diagonal. Draw a diagonal. That is, draw a diagonal. The connecting, that is A, B, C, D. And here there are two triangles. And here also, and next polygon. And this is with the, that is 1, 2, 3, 4, 5, 6. That is, here we can draw, that is here. That is, here we get 1, 2, 3, 4 diagonals. We draw three diagonals and we get 4 triangles. That is, here there is a triangle, and second one, third, fourth. And the sides are 1, 2, 3, 4, 5, 6. That is, from this we can see that here there are 4 sides and the triangles are 2. That is equal to 4 sides minus, that is equal to, we get only 2. That is minus number of sides minus 2 triangles we get. Number of sides, that is from here we can observe that the number of triangles we get is less than 2 of the sides. Number of sides, that is less than the number of sides. And here also there are 6 sides and we get, that is 1 to 4 triangles. 6 sides and 4 triangles. 6 sides and 4 triangles. That is, here we can say that the number of sides, if the number of sides is equal to 4, we get, that is, number of sides is equal to n, we get n minus 2 triangles. We get n minus 2 triangles. That is, from here, that is if a polygon with n sides, the number of triangles is equal to, number of triangles we get is equal to n minus 2. N minus 2. Sum of the angles of a triangle. Angles of a triangle, we know that angles of a triangle is equal to 180 degree. Sum of the angles of a triangle is equal to 180 degree. And the sum of angles of n minus 2 triangle, and the sum of angles of n minus 2 triangles is, what is it? N minus 2 triangles is equal to, yes, that is n minus 2 into 180 degree. N minus 2 into 180 degree. And after that it is sum of the angles of a polygon. Sum of the angles of a polygon. Here, write it here. Sum of the angles of a polygon with the n sides. With the n sides is equal to n minus 2 into 180 degree. N minus, that is the sum of the angles of polygon with the n sides. N sides is equal to n minus 2. That is the number of sides is equal to n. That is minus 2. We get the, that is less than n. That is 2 less than n. That is, we get the triangle, number of triangles. That is n minus 2 into 180 degree. That is, here we can split it up. That is n minus 2 into 2 into 90. That is equal to, multiplying this, that is 2n minus 4 into 90 degree. This is 90 degree. 2n minus, this is the formula for calculating the sum of the angles of a polygon. That is 2n minus 4 into 90 degree. 2n minus 4 into 90. This is the formula for calculating sum of the angles of a polygon. Okay, there is a question for you. The sides of a hexagon are produced in order if the measures of exterior angles so obtained are 6x minus 1 degree, 10x plus 2 degree, 8x plus 2 degree, 9x minus 3 degree, 5x plus 4 degree, and 12x plus 6 degree. Find each interior angle. What is it? The sides of a hexagon. The sides of a hexagon are produced in order. Produced in order. That is, we know that the sum of the exterior angles of a hexagon produced, that formed by produce, we get the sides of sides is equal to, the sum of the sides is equal to 360 degree. This is equal to 360. Sum of the exterior angles of a hexagon, produced, that is formed by produced, that is produced, the sides is equal to 360 degree. That the exterior angle of a hexagon is equal to, formed produced, we get 360 degree. And here the exterior angles obtained are 6x minus 1 degree, 10x plus 2 degree, 8x plus 2 degree, and 9x minus 3 degree, that is 5x plus 4 degree, and 12x plus 6 degree. That is, from this the exterior angle produced and the sum of the exterior angle produced by a polygon is equal to 360. For each and every the sum of the exterior angle that produced by a polygon, the sum of that exterior angles is equal to 360 degree. Here also this we get, that is the angles are 6x minus 1 plus 10x plus 2 degree plus 8x plus 2 degree plus 9x minus 3 degree plus 5x plus 4 degree plus 12x plus 6 degree is equal to 360 degree. That is the sum of the exterior angles of a polygon, that is equal to 360. And then adding this, we get 6x plus 10x plus 8x plus 9x plus 5x plus 12x. We get 50x. And then after that, minus 1 plus 2 minus 3 plus 4. And this is 6. And this adding and subtracting this, we get plus 10. 50x plus 10 degree is equal to 360 degree. And taking this 10 to the right side, that is 50x is equal to 350, and x is equal to 350 by 50 is equal to 7. And the value of x is equal to 7, substituting the values in this equation, that is 6x minus 1, 10x plus 2, 8x plus 2, 9x minus 3, and 5x plus 4, and also 12x plus 6. Substituting this x is equal to 7 in this value, that is 6 into 7 minus 1 is equal to, we get 41. And the angles are, first one is 41, and then 10 into 7 plus 2 is equal to 72. And third one, 8 into 7 plus 2 is equal to 58. 56 plus 2, 58. And then 9 into 7 minus 3. 9 into 7 minus 3 is equal to 63 minus, that is 60. 60, and then is equal to 5 into 7. 35 plus 9 is equal to 39. And the last one, it is 12 into 7 plus 6 is equal to 90. These are the values of this 41 degree, 72 degree, 58 degree, 60 degree, 39 degree, and 90 degree. These are the values, the exterior angles of a hexagon. These are the exterior angles of a hexagon that's produced. That is the value of this exterior angles of a hexagon. Okay, next question. The interior angle of a pentagon are in the ratio 4:5:6:7:5. Find each angle of the pentagon. What is it? The interior angle of a pentagon are in the ratio 4:5:6:7:5. We want to find the value of each angle, each ratio. That is, we know that let the interior angles of a pentagon is equal to, let the interior angles of the pentagon is equal to this, we can write it as 4x, 5x, 6x, 7x, and again 5x. And their sum is equal to, and we want to find the angles. That is, the sum is equal to 4x plus 5x plus 6x plus, find this first, 5x. Find the sum of this ratios, that is 4x plus 5x plus 6x plus 7x plus 5x, that is we get 27x. We get the value, that is from this sum we get 27x. And the sum of the interior angles, sum of the interior angles of a polygon is equal to n minus 2 into 180 degree. N minus 2 into 180 degree, that is equal to, here how many, that is 1, 2, 3, 4, 5. 5 sides, that is 5 minus 2 into 180 degree. 5 minus 2, number of sides is equal to 5, and minus 2, that is less than, that is 2 less than number of sides, that is 5 minus 2 into 180 degree is equal to 540. 540, that is, we know that the sum is equal to 27, that is 27x is equal to 500, the sum is 540, and x is equal to 540 divided by 27, that is equal to 20. So sum is equal to, value of x is equal to 540. Substituting this x in here, that is, and the values are 5 4s are 80. Sorry, that is 20. 20 into 4, that is 4 into 20 is equal to 80. 80, and then 5x. 5 into 20 is equal to 100. And next one, that is equal to 6 into 2 is equal to 120. 6 into 2 is equal to 6x, that is 120. 120, and then 7 2s are 40 and 140, and again that is, next is 5x, that is 5 into 20 is equal to 100. These are the values of the interior angles of a pentagon. Interior angles of a pentagon, that is 80, 100, 120, 140 and 100. That is so. I hope you understood this part of this lesson. See you in the next part.